Yep. Hi, everyone. My name is Zivia, and this is Jingwen, and we're here to present to you Bioscribe. So first, let's go over the overall goal. So our goal is to take clinical research papers on traumatic brain injuries and then convert it into a structured data set that has information on each and every cognitive study or cognitive test that was performed within the study. So let's look at the current process that's being followed by Dr. Malieva and her team. So currently, this process is very manual. So they manually go through PubMed, run a search query, and get all of the TBI papers. And then they scan through each paper to identify whether or not it's relevant for their use case. And then finally, they read through each and every paper to extract all the required fields for all of the tests. And this is used for systematic literature reviews. So what is Bioscribe? So Bioscribe comes in because it's a construction platform that uses LLM to reduce the manual efforts and the time that is taken to create these structured data sets. So let's look at the retrieval and the labeling of data. So what we did was we looked at 25 different papers, and we manually read through them and labeled them to create our own structured data set. And this is what we used as our ground truth when evaluating how well our extractor agent performed. So for the architecture diagram, I'll quickly go over the different parts, and then we'll go in more detail. So the TBI study comes from the PubMed API or as PDFs. We judge whether it's good or not, and then we extract the fields, run validator to see how confident we are in our extraction, and then we open it up to the human user to see if they have any manual edits they want to make. And this is inserted into the structured data set. So some of the fields that we're looking at for the output is like the cognitive test name, participant information, so age, education, sex, country, so on and so forth, and assessment details, especially we're looking at the baseline and the follow-up, and the time that it was performed after injury. Additionally, we're also looking at cognitive domains, which is like a binary field saying which parts of the brain were tested.
This is the screener agent. We have 3 steps. The first step is to use GPT-4o to extract each paper's title and abstract based on our prompt. And the second step is to see if there is some undecided paper that needs full text. And these ones will be inserted into the step 3's agent and using a narrowing prompt and giving us a result. The accuracy of this agent is very high. We tested on 28 relevant papers and 5 irrelevant papers, and only 2 of them failed. And the failed reason is some papers are written by the agent as too specific and not following on the overall outcome of cognition. And there are some manual works of this screening, and some information is hidden in the tables or graphs. This is the example of one of the failed results. You can see the reason that there are some specific scores that, not following on the overall assessments.
Yeah, so the extraction agent has 3 different steps. So first, we look through the paper to identify all of the cognitive tests that are mentioned within the study. The second step is to run extraction on all of the cognitive tests to extract the fields that I mentioned earlier. And then third is we run image processing on each image that's available on the website to see what other information we can do. So this can edit or add different cognitive tests. So the overall accuracy we saw was around 86% per cognitive test. However, there were a couple of issues that we noticed that sort of reduced our accuracy. So one is identifying subtests. So sometimes we notice that when, like underneath a specific category, some tests weren't identified. And this is especially the case for like subtests. And then for, sometimes we noticed that some values were confused between the control and injured cohorts.
This is validation agent. We first will load the paper resources, including images and extract fields, extractors results, and running on these 5 fields, evidence, confidence, hallucination risks, consistency, and completeness. Then using these 5 fields to calculate a composed confidence score for the human to review, make a suggestion. And this is the UI of the review. Basically, it's just the A demo of the interface of the review includes the extractions fields and also the confidence score and priority of each records for the human to review and to edit and then save the data into database. And our discussion has three. First is the screening stage. We have to split this prompt into two steps. Step 1 and Step 3 as mentioned, because one big prompt will be lose some performance, and second is the image processing is the key, especially for extraction, because there are some image format hidden in the HTML full text. And third one is the speed, because we want to speed up the extraction process of the experts. So this Bioscribe really succeeds of this goal, and each paper will just cost us 2 minutes or less for the whole whole research work. That's all. Thanks for listening and questions.